This is the Daily Space for today, Tuesday, August 4th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. In bringing you the news each day, we review often a dozen papers to pick out which stories are the most interesting to us that we hope will also be more interesting to you. Lots of factors go into picking stories. How novel is the science? How exciting are the results? Do we actually care about those results? Sometimes I'll be reading a journal article and realize I don't actually care about carbon-rich supernovas studied in the X-rays. And those are the stories that don't make it to this show. Something else happens while picking stories. Somehow, day after day, themes seem to emerge that weave our stories together. This isn't something that happens on purpose when picking stories. But like some game of what do these all have in common, I'll start reading the articles behind our chosen stories and discover some idea that ties it all together. The reason I bring this up is because yesterday's science all fell nicely into the bin of these are pleasing observations that discover everything is as predicted kinds of results. But today the science is much more along the lines of new analysis pointing out all the ways the universe is not as it should be. Take the galaxy cluster, Sparks 1049. It is out there forming 900 some odd stars per year out of the gas and dust between galaxies. This is not normal. I actually studied galaxy clusters as a grad student, and normal massive clusters are filled with extremely hot gas that can't form stars because the atoms are moving too fast to consider collapsing into stars. This gas is generally heated by jets from a central supermassive black hole that is active in the central galaxy, a CD galaxy that marks the cluster center. This supermassive black hole is active because it is feeding on material driven into its core through interactions with other systems, many of which it's consuming. But in Sparks 1049, it doesn't so much have a central CD galaxy as it has an off-center, could have been a CD galaxy. And that galaxy isn't active and isn't heating all the gas in the intergalactic spaces in this cluster. Thus, that gas has a chance to cool, collapse, and form stars in a very not normal way. It's as if the universe said, let's move this galaxy over and see what happens. And the result was stars. Lots and lots of stars. The team behind this work, which appears in the astrophysical journal Letters under the first author J. Hlavik Lorando, theorizes that this kind of a system may have been common in the early universe when clusters were still settling into their final shapes and may have been responsible for forming a lot of the universe's early stars. Now, this galaxy cluster is not the only weird thing going on in today's news. Looking closer to home, we have a story of water on Mars appearing in Nature Geosciences under first author Grau Gallifrey. Now, for those of you who have been following the plight of study of waters on Mars, you know that over the past couple of decades, we've gone from thinking that all the amazing features we see on Mars were probably formed by, well, aeolian processes, sand blowing in the wind, to thinking that they happen via fluvial processes or liquid flowing across the surface. And for there to be liquid flowing on the surface of Mars, we had to imagine a history in which Mars was once upon a time warm and wet. Now, the thing is, you can get liquid water in lots of different ways, and we have liquid water on Earth in lots of different places. And the science of comparative geology allows us to look at what's going on here and match it to what's going on there. and researchers here on Earth looking around our planet, trying to find riverbeds and valleys that looked like those that we see on Mars, found them. They found them on Devon Island in the Arctic Sea around Canada. And these riverbeds weren't formed by water flowing across the surface of the earth under open blue skies. They were formed by rivers rushing underneath the pressure of massive glaciers. And this changes our thinking on Mars, reminding us that Mars, we know, can have massive amounts of ice on its surface. We see this in its polar caps. And this tells us that maybe a lot of those rivers and valleys we see carved on Mars weren't carved by rivers we'd recognize, but were instead carved by rivers under glaciers such as we rarely get to see. And this kind of comparative geology is sadly made possible thanks to the recession of, well, glaciers on our own planet that allow us to see what the geology underneath them looks like. So maybe Mars wasn't as warm in the past as we thought for as long as we were starting to hope. We don't know. This is one of those things about Mars where we just have to say, we don't know. We're still trying to figure it out. And every time we look at the observations, we learn something new. And it turns out Mars is far more complicated and interesting than we, well, had previously given it credit for. Now, continuing our thread of things that aren't quite as they should be, we have a story of what happens when two neutron stars merge in a way that we're just now starting to observe thanks to LIGO and the other gravitational wave detectors around our planet. In a new paper appearing in the monthly notices of the Royal Astronomical Society by Sebastiano Bernuzzi, researchers have begun modeling what happens when two very different massed neutron stars collide. Now, neutron stars have a very small range of masses they can exist at. Anything that is a dead star, no longer undergoing nuclear reactions, that is under about 1.2 solar masses is going to form a white dwarf star that is supported by electron degeneracy pressure. Once you get over that 1.2, those electrons no longer exert enough pressure and the object collapses down, protons and electrons combining to form neutrons in a massive blast of energy. Now, if you take that neutron star and you keep piling mass on until it's somewhere around 2.5 or 3 solar masses, the neutron degeneracy pressure that is now supporting that dead star can't do it anymore. And it collapses further down to form a black hole. And we don't know what black holes are. Now, when two neutron stars merge, which is a thing that happens and produces a whole lot of gold, when neutron stars merge, it's thought that in general they form a black hole, exceeding that 3 solar mass limit. And when this occurs, no light escapes. The black hole just consumes everything, except for the gravitational waves, which is what we're detecting here on Earth. Now, the thing is, you can have a 1.3 solar mass neutron star and a twice as large 2.5, 2.6, we're not really sure, neutron star. And in new models, looking at what happens when these two objects come together, it appears that that more massive neutron star will shred the smaller neutron star, causing light to be released, marking what is happening with dramatic sky events that maybe someday we'll get to see. It's showing us that sometimes in the process of forming a black hole, if things are just different enough, you can get light. And so, in all three of these stories, we see the situation of things are just slightly sideways of what we expected. An off-center galaxy, a river under a glacier instead of on the surface, neutron stars merging that are very different masses. And that changes everything and forces us to think about the universe a little bit more broadly. And that is kind of awesome. And that is the Daily Space for today. Thank you all for being here.